Okay, so before we start talking about object-oriented programming, we need to understand what an abstract data type is. So an abstract data type is a coordinated group used to solve a particular problem. And that coordinated group consists of three things. One, algorithms. So an algorithm is just a set of instructions that solves some particular problem. Two, data structures. A data structure is the set of variables that an algorithm uses to solve that particular problem. And a data structure can be as simple as an array or something more complicated like a linked list. And three, interface functions. So after we have defined our algorithms and data structures, we create interface functions that give us access to the abstract data type itself. Now, if this doesn't make sense or seems a little bit too abstract, don't worry about it. I've created plenty of diagrams to help me explain what an abstract data type is. Okay, so as I just mentioned, algorithms, data structures, and interface functions. These three things make up an abstract data type. And to solve a problem, we have to design our algorithms and data structures together. And once we have done that, we then provide a set of simple interface functions to let the programmer use them easily. Okay, now let's look at a diagram. So an abstract data type is made up of three things: algorithms, data structures, and interface functions. Here, I've defined a very simple data structure, which is an array containing 4 elements. Now that we have some data, we would like to do something with this data. And at this point, we can begin thinking of some algorithms that will take this data and do something useful with it. So I've gone and created 4 algorithms. So the first algorithm takes the array and finds the maximum value. We can also find the minimum value. We can find the mean, or otherwise known as the average. And we can also find the median. Now, don't worry too much about this particular syntax here. This just means that when we call, for example, find max value, that the return type, or the value that is returned after the function executes, will be an int. Now, we can imagine that, for example, finding the maximum value is not as simple as calling one function. Suppose, just for the sake of the example, that to find the maximum value in the array, we need to execute 3 or 5 different functions before arriving at the maximum value. And this is typically the case when you're working on very hard problems. Things aren't so simple. So what can we do? Well, we can define a set of interface functions that are simple and easy to use. So I've gone ahead and defined 4 of them: max, min, mean, and median. So when the user uses these interface functions, our interface functions will call our algorithms for us, which will then operate on the data structures that we have defined. And after the algorithms are done operating on these data structures, we will hopefully get a result. Okay, one more time, but with diagrams this time. So an abstract data type is a coordinated group of data structures, algorithms, and interface functions that are used to solve a particular problem. In an abstract data type, the data structures and algorithms are secret, and no one outside the abstract data type needs to know how they're implemented. So the data structures and algorithms are the secret sauce. And the only thing that we expose to the user are these interface functions. This is how we access the abstract data type itself. And so typically, we build programs from a collection of abstract data types, each of which solves a different subproblem. Okay, now that we understand what an abstract data type is, we can finally begin answering the question, what is object-oriented programming? Object-oriented programming is a model based on the abstract data type. In C++, we use classes to define abstract data types in our programs. Each C++ class can hold algorithms, data structures, and interface functions. Now, where have we heard that before? To access the class or to use the class, we use the interface functions that we have defined. In object-oriented programming, programs are constructed from multiple self-contained classes. Classes talk to each other only by accessing the public interface functions. Each class knows nothing about how the others work inside. Okay, so to sum up, object-oriented programming uses classes, otherwise known as abstract data types, to build programs. And so a class is a self-contained problem solver. So what does this look like in C++? Now, as I mentioned at the beginning of the video, the C++ code that I will be showing you is for pure pedagogical reasons. So I will not be talking about constructors or destructors because it will just complicate things. In fact, I can make an entire video series on just constructors alone. And I can also make a mini series on destructors. In fact, before we can even start to properly understand why destructors are important, we would need to learn about pointer variables and how they come into play when we are dynamically allocating memory. So again, the purpose of this video is just to explain what object-oriented programming is. Okay, on to the C++ code. So first we need to write the skeleton and give the class a name. And to do this, we use the class keyword followed by the class name and open and closed curly braces. And make sure to put a semicolon. I always forget about the semicolon. So anyways, the next thing we do is define the public interface or the interface functions. And to do that in C++, we use the public keyword followed by a colon. Now, anything placed underneath here will be the public interface. And this is precisely where we define our interface functions. So I've gone ahead and defined 4 interface functions: min, max, mean, and median. Now again, don't worry too much about the syntax. If you're really curious and you really want to learn more about C++, there are plenty of other YouTube videos that teach you the C++ syntax and how to use C++. Next, we want to define our class's private variables and functions. And to do that in C++, we use the private keyword followed by the colon. And anything placed under the private keyword, well, it's private. And this cannot be accessed by the user or anyone who is using this class. So again, this is precisely where we define our data structures. And so I've gone ahead and defined an array containing 100 slots. And this array can only contain ints or integers. Next, we define our algorithms. And I've gone ahead and defined 4 algorithms: get min value, get max value, get mean. And so now, bringing it all together, we know that a class is an abstract data type. And we also know that an abstract data type is a coordinated group of data structures, algorithms, and interface functions. And remember, our data structures and algorithms, these are secret. These are the secret sauce. And these will be hidden from the user when they use this class. The only thing that is exposed to the user will be the interface functions that we have defined. And so with that, I'll go ahead and end the video right here because I do not want this video to be too long. As I mentioned, the purpose of this video is just to explain what object-oriented programming is. If you like the video, like and subscribe. If you have any questions or suggestions, make sure to leave those down below in the comments.